You can't just discuss forces and not mention this guy, Sir Isaac Newton, and his 3 laws of motion. The first law, the law of inertia, pretty much just states an object at rest stays at rest unless an external force is applied to it. For example, a box. This box is not moving, and it won't be moving unless another force is acting on it. This also works with things that are in motion or have constant velocity. For example, let's say this car is moving at 50 meters per second. This car will continue to move at 50 meters per second and won't slow down or speed up unless another force acts upon it. The first question we have to ask ourselves is, what is a force? Well, according to its definition, a force is any push or pull between 2 or more interacting objects. These interactions can be with or without contact. An example of this can be seen in these 2 images. The first can be described as a contact force. The second, a non-contact force. For now, let's focus on contact forces. We know that an object at rest will stay at rest unless an external force is acted upon it. And the same thing goes for this box. It won't move unless something forces it to. For example, let's say this guy wants to push or pull this box. Well, to do that, he has to exert a force on it. And let's say he pushes the box to the right with a force of 1 Newton. And if you didn't know, 1 Newton is the equivalent of 1 kilogram meter per second squared. Let's look back at this image. We can see that the man is pushing on the box with a force of 1 Newton to the right. Well, now that he's pushing the box should be moving, right? Sometimes this doesn't happen. The box's mass can sometimes overpower the force exerted. Why this is can be explained with Newton's second law of motion. F equals ma, or force equals mass times acceleration. With this equation, we know that the force applied is directly proportional to its acceleration. When we want to find either the force or the acceleration, all we have to do is use these 2 equations. And really quick, let's mention Newton's third law of motion. Well, Newton pretty much said in this law that for every action there's an equal and opposite reaction. Okay, let's look at the images from before. If we keep everything constant and still say that this guy is pushing the box with a force of 1 Newton to the right, then the box should be pushing back with the force of 1 Newton on the man. Same thing goes for this car. If the car is pushing on the road with a force of 5 Newtons, then the road is pushing the car forward with a force of 5 Newtons. This even works with things at rest. The box is pushing down on this table, and the table is pushing back on the box. Let's look at non-contact forces for a second. When it comes to these forces, they happen at a distance. Whether it happens over a few meters or a few centimeters, these objects cannot be touching. Things like magnetic force and gravitational force are prime examples of contact at a distance forces, or non-contact forces. And so that the subject can hit home, why don't I show a quick example? I think that's good.